Hello, my viewers all over the world. Today I bring you a new package. Today I have a logarithm equation. We have a logarithm of numbers and we have logarithmic equation. So this is a typical example of what I mean by logarithm equation. So where you'll be given log 64 in base x equals to 2. So when you come across this type of logarithm equation, all you need to do is to know that this is the raised to power. This base comes here. Then the 2 becomes the raised to power. So solution, what I will do here is 64 is equals to x raised to power 2. That's the first thing I will do. Now, at this point, I'll ask myself, what can I raise to power 2? X squared is equals to 64. That is to say, my x, I have to square root both sides anyway. So this is going to be square root of x squared and square root of 64. Where the square root will take care of the square, leaving me with x or cancelled. Now I have here square root of 64 will give me 8 equals to x, and that is how simple it can be. So logarithm equation is actually not supposed to be a problem when you see it next time. Always know that this is actually the raised to power. So let us look at example 2. In example 2, they gave us that x is equals to log 12 in base 2, subtracting log 3, and also in base 2. So what I'll do, I quickly solve it. X will be equals to, I have to group the logs. I group them. Log, open a bracket. In this type of logarithmic equation, the subtraction sign changes to division sign. So I'll now say 12 divided by 3. Remember, they are both having the same base. The base is 2. So x continues log, this and this will give me 4 in base 2. So it's now looking like the first example. So what I will do is also to know that this is the number here, whatever I have here is the raised to power. So I have 2 raised to power x is equals to 4. I've equated it. So now, what will I raise to power to get 2? Now, 2 is the least base. I have to reduce this in powers of 2. That's 2 raised to power x is equals to 2 raised to power 2. So I've reduced 4 to be raised to power 2. So now, something can cancel, 2 can cancel 2. We have x as equals to 2. In the third example, unlike what I did in the second example, this time around, I am going to change the addition sign to the multiplication. So I have to group them also. This is going to be log 12 times log 2. This time around, the bases are not there. But I want to let us know, by default, once you're working in doing something on logarithm and the bases are not there, is by default in base 10. So automatically I have 10 there, but I didn't see it. I already know that is what it is. So it's equals to log x. So here is giving me log 24 is equals to log x. So I will now cancel out the logs to have x as 24. Example 4. In example 4, this is different. No log. This log is by default in base 10, and this is in base 2. Log 32 in base 2. So we're asked to find the value of this. All I need to do is, since this is not in logarithm form, I need to trash this and this separately to get their real values where I can now substitute. So I'm going to trash this separately. I have log 0.0001 in base 10 equals to x. Remember what I told you in my previous examples? All you need to do is know that this is by default in base 10. So all you now need to do is 0.0001 is equals to 10 raised to power x. 10 raised to power x, because this is raised to power. This is now going to be, I will convert it to fraction all over. Anywhere I see this small point, I put my 1. The rest of the digits will take 0. So this alone means 1 over 10,000 equals to 10 raised to power x. I now need to put all of them in the same line. So this is going to be 10 raised to power minus 4. How many zeros do we have here? 4. That is 10 raised to power minus 4 equals to 10 raised to power x. Now, 10 can cancel out 10, leaving us, therefore, my x is equals to minus 4. So I'll be able to take care of this. I'll do the same thing to this one. I will quickly do for the other one. This is log 32 in base 2. I need to get the value, so I can set equals to x also. Exactly what I have been doing, I will do here. This is the raised to power. So here I will equate 32, therefore, is equals to 2 raised to power x. So I'm going to raise this to power 2. So how many will I get? I will have 2 raised to power 5, which is the same thing. This 2 raised to power 5 is the same with 32, which is equals to 2 raised to power x, where the bases can cancel. I will have my x as equals to 5. So it simply means that I've known the value here, I know the value here, and I've also gotten the value here. Combining it, since I know this is 16 raised to power 3 over 2, plus I got here as minus 4, and this gave me 5. So I have to work on them. So here I have 16 raised to power 3 over 2 minus 4 and then plus 5. Here became minus because plus multiplying minus, I will have a minus. So this is indices, which I trashed before now. Here, this is going to be square root of 16, whatever I have, raised to power 3. I will have a minus 4 plus 5. Here, I will have 4 raised to power 3 minus 4 plus 5. This is 4 raised to power 3. I will have 4, 4, and 4. 16 times 4. This is 24. Carried to 64. So here it gives me 64 minus 4 plus 5. So this is 64 minus 4, which is 60 plus 5. I will have 65 as my final answer. So as you can see, it is not difficult. All you need to do is to know how to do them individually. So please do not hesitate to like, subscribe, and share, and follow for more. Thank you.